For the presentation, we will be covering the history, manufacturing, chemistry, types, and applications.
First, let's distinguish between cement and concrete. It's often said that cement is to concrete as flour is to cake. So cement is the bonding agent or the glue that's used in concrete. The primary difference between concrete and cement is that concrete is the composite material made of water, aggregate, and cement. Cement is a very fine powder made of limestone and other minerals, which absorbs water and acts as a binder to hold the concrete together.
Today's modern ready-mix concrete is very similar to the concrete that the Romans used to build the Colosseum and the aqueduct. But today's technology has enabled us to introduce chemicals and many different changes of aggregates and cement to achieve the desired results for the various projects. For example, we might use the same ingredients in concrete used for skyscrapers and backyard patios, but we would use different amounts of ingredients.
In the beginning, cement was being used by the Egyptians about 2,600 years ago. This cement composition consisted of lime and clay. In the 1st century, the Romans perfected this binder by adding volcanic ash soil, known as pozzolan, which gets its name from the region of Pozzoli. They discovered this mixture would set underwater. In 1817, Louis Vicant redefined this binder by precise measuring, mixing, and heating of the lime and clay. This cement composition was then redefined and patented in 1824 by Joseph Aston. He called it Portland, a slow-setting cement.
Cement is a manufactured product made up of lime, iron, silica, and aluminum-bearing materials. These are all either obtained by cutting, blasting, or mined. These materials are gathered in very specific quantities and heated up to around 1500 degrees Celsius in a kiln. They are heated to the point where they are almost fused together and cooled very quickly and grind to fine powder. This material is then mixed with gypsum and Portland cement is produced. Gypsum is what we all know as drywall and acts as an inhibitor to prevent flash settling.
When the raw materials are heated to 1500 degrees Celsius, a complex series of chemical reactions create 4 main compounds which make up cement. These are tricalcium silicate, dicalcium silicate, tricalcium aluminate, and tetracalcium aluminoferrite. These 4 compounds, as well as minor amounts of free lime and other oxides, leave the kiln as clinker. After the clinker has cooled, a small amount of gypsum is added, and the mixture is pulverized and ground to obtain finished Portland cement. When Portland cement is mixed with water, a chemical reaction occurs. Hydroxyl ions are released from the cement as it dissolves in water. Portland cements are called hydraulic cements because they harden and set by reacting chemically with water. This complex reaction between water and cement is called hydration, and it's only partially understood. Mixed with water, silicates C3S and C2S, which constitute up to 80% of Portland cement, produce similar hydration products. These products produce C3S2H3, also called CS gel, which makes up 70% of cement and gives it its strength. At first, hydration reactions are fast and there's a dense layer of CS gel. But within a short amount of time, hydration stops for what is called an induction period. And eventually, hydration picks up again, allowing more water to reach certain grain surfaces. The onset of setting and early strength development is controlled by C3S because it hydrates quicker than C2S and because it's more abundant. The C2S component affects the hardened cement's final strength.
The products of cement and water set in a few hours, but harden over a period of weeks. A typical concrete sets in about 6 hours and develops a compressive strength of 8 MPa in 24. The strength rises to 15 MPa at day 3, 23 MPa at week 1, 35 MPa at week 4, and 41 MPa at 3 months. In principle, the strength continues to rise slowly as long as the water is available for continuous hydration, but concrete is usually allowed to dry out after a few weeks and causes strength growth to stop.
There are different types of cement to meet different physical and chemical needs. There are 5 main types of Portland cement, and all are approved by the CSA. General use hydraulic cement. This type of cement is used in concretes that do not require the use of specialized cements. This general cement can be used anywhere from floors to pipes and tanks. Moderate sulfate-resistant hydraulic cement is used where precaution against moderate sulfate attack is important. This is used in normal structures or parts of structures that are exposed to soil or groundwaters where sulfate concentrations are higher than normal. High early strength hydraulic cement. This cement is pretty much the same as general cement mixture, but is ground into a finer powder. It is used when forms need to be removed rapidly or when the structure must be put into service quickly. In cold weather, its use reduces the length of the curing period. Low heat of hydration hydraulic cement is used where the rate and amount of heat from the hydration must be minimized. It develops strength at a slower rate than other cement types. For use in massive concrete structures such as large gravity dams, where the temperature rise resulting from the heat of hydration must be minimized, or thermal cracking may occur. High sulfate resistant hydraulic cement is used in concrete exposed to severe sulfate action, principally where the soils or groundwaters have high sulfate content. Another popular cement is moderate heat of hydration hydraulic cement. This cement is similar to low heat of hydration hydraulic cement.
So these two graphs provide the basic justification in selecting the cement for engineering application. So for instance, for massive concrete structure, hydration heat is an important consideration because excessive temperature increase will cause expansion and cracking. Therefore, type 4 cement should be the first candidate and type 3 should not be used. For a foundation exposed to groundwater with high concentration of sulfates, high sulfate resistance is needed. Thus, type 5 should be selected. If high early strength is needed, type 3 will be the best choice. But generally, type 1 is the most popular cement for civil engineering.
Portland is the most common type of cement and is used in concrete, as well as stucco, mortar, and grout. The low cost and widely spread availability of limestone shales and other natural occurring materials and/or recycled materials from other processes used in Portland cement makes it one of the low-cost materials widely used over the last century. Concrete is one of the most versatile construction materials available in the world. You might be wondering why it is called Portland cement. Well, when it was discovered, it resembled a lot like a stone from the Isle of Portland off the coast of England. Thank you for watching this presentation.